Hello, and welcome to this session. Today, we'll explore how common probability distributions help data scientists understand patterns, variability, and trends in data. Probability distributions assign probabilities to possible values of a random variable. They help describe data spread, central tendency, and variability. Examples include the number of customers or defective products. Distributions are crucial for statistical methods and machine learning algorithms. They provide insights into patterns and likelihoods in datasets. Distributions are categorized into discrete and continuous types. Discrete distributions involve countable values like customer arrivals. Examples include binomial and Poisson distributions. Continuous distributions involve measurable values like height and weight. Examples include normal and exponential distributions. Distributions are described by central tendency, variability, and shape. Central tendency includes mean, median, and mode, indicating data concentration. Variability measures include range, variance, and standard deviation. Shape involves symmetry, skewness, and kurtosis. These characteristics define data distribution behavior. The normal distribution is a symmetrical bell-shaped curve. Mean, median, and mode are equal, clustering values around the mean. It's vital in statistics due to its application in natural and social phenomena. Examples include human height and exam scores. Many statistical tests rely on this distribution. The binomial distribution model's successes in fixed independent trials. It's used in scenarios like defective products or marketing responses. Poisson distribution models events within a fixed interval, such as call center calls. It's useful for analyzing random event frequency. Both distributions are key in discrete probability analysis. Uniform distribution assigns equal probability to all outcomes, like a fair die roll. Exponential distribution describes time between events in a Poisson process. It's applied in reliability analysis and waiting time problems. Examples include customer arrival times and machine failure intervals. Both distributions are crucial for continuous probability analysis. Distributions help analysts understand data structure, central tendency, and variability. Many statistical methods assume specific distributions, like normal for hypothesis testing. Machine learning uses probability distributions for uncertainty modeling. Understanding distributions aids in detecting anomalies and outliers. They guide appropriate model selection. Data scientists visualize distributions with histograms or density plots. They examine mean, variance, and standard deviation. Identifying skewness or unusual patterns is crucial. Comparing observed data with theoretical distributions helps model selection. These steps ensure accurate statistical modeling and analysis. Continuous distributions involve measurable variables, like height or temperature. Discrete distributions involve countable values, like customer counts. Continuous examples include normal and exponential. Discrete include binomial and Poisson. Understanding these differences is crucial for data analysis. Selecting the right distribution enhances model accuracy. The normal distribution is defined by a symmetrical bell-shaped curve. Mean, median, and mode are equal, centralizing data values. It's characterized by parameters, mean and variance. Standard deviation affects curve width, indicating data spread. It's a fundamental distribution in statistical analysis. This is the main callout for this scene. The normal distribution appears in natural and social phenomena. Examples include human height, exam scores, and measurement errors. The central limit theorem supports its widespread use. It's essential for statistical analysis and hypothesis testing. Many processes are influenced by numerous small random factors. Continuous distributions include uniform, normal, and exponential types. Uniform distribution assigns equal probability to values in a range. Normal distribution models symmetrical data clusters. Exponential distribution describes time between events. Each distribution has specific parameters and applications. Discrete distributions include Bernoulli, binomial, and Poisson types. Bernoulli models single trials with two outcomes. Binomial extends to multiple independent trials. Poisson describes event counts in a fixed interval. Each distribution has specific parameters and applications. Probability distributions are vital for data analysis and data science. Understanding their characteristics aids in accurate model selection. They help interpret data patterns and variability effectively. Distributions guide statistical methods and machine learning algorithms. Mastering them enhances predictive modeling and data insights. For any support or questions, contact us on WhatsApp at 0748 436 1688. We are happy to assist. Thanks for your attention, and see you soon.